Alright, so for the third video here, I'm going to start with 20. If you're looking for number 19, I put that on the second video just because we did the other proofs on the second video. So for these, I don't know, I kind of threw these in. They don't really match the 7-3 section. They're more 7-1, but and then 22 is like 7-5. But I had to put them somewhere. So anyways, for number 20, it says you want to determine the height of your school building. So right there, I know I'm finding height. So I know I am not finding a total. Okay, because it's not like find the perimeter, find, supplementary angles, complementary angles, something like that. It says the height. So if it says just the height, just the length, I know I'm not doing a total. When I'm not doing a total, proportion, 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 proportion. Okay. When I am doing a total, remember you got to add the pieces. Okay. So I know I'm doing proportion here. Okay. So it says the building casts a 6-foot shadow. I went ahead and changed it to inches, and you'll see why here. So I got 72 inches. At the same time, you cast a 15-inch shadow. So I changed both to inches, or I changed the 6 foot to inches just because it was easier. So 6 times 12 gets me 72 inches. If you are 5 feet tall, so that would be 60 inches, how tall is the school building, which is X? So when I go to set it up, the key is drawing these out. Okay, and they don't have to be fancy drawings. You'll notice I've just got sticks. Here's my height, here's my shadow, here's the building's height, here's its shadow. So you've got X over 60, because those correspond, is going to equal 72 over 15. At this point, you should know how to cross multiply. X times 15 is 15x. 60 times 72 is 4,320. You'll have to excuse my math there. When I did the key, I didn't have a calculator. Okay, which reduces down to 288 inches. I would accept that since I didn't say what units it is. If you want to divide by 12 to get it into feet, 24 feet. That works. Okay. For 21, it says in geometry class, the ratio of A's to B's to C's is 2 to 3 to 4. Okay, now I've got an extended ratio, which means there is no possible way I can do proportion here. Okay. So if there are 27 students making an A, B, or C, so since I'm only talking about A, B, and C, 27 is a total. Okay, so the total number of students is 27. That means I'm adding the parts of 2x, the 3x, and 4x. Combine like terms, 9x is going to equal the total of 27. So it means each x is 3. So basically, I reduced this ratio by 3. So to find the number of a's, it would be 2 times 3, or the 2x, which is 6. Find the number of b's, 3 times 3, 3x, which is 9. If I wanted to find the number of c's, 4 times x, 4 times 3, which is 12. Alright, for 22, this was actually from 7.5. I don't know why I decided to put it in here, but anyways. So this was that, side splitter theorem. Okay, and this one's actually not too bad. So I've got 6 down the side here is going to correspond to x plus 6 in the big triangle. So remember, I've got small triangle and big triangle. So x is going to correspond to x plus 6. X minus 1 is going to correspond to 2x plus 4. Cross multiply. Make sure you FOIL out. The pre-AP you'll have to FOIL. Regular CB. I do not believe that I put any foils on there for you. Okay. So when I go to multiply, x plus 6 times x minus 1, I've got x squared plus 6x minus x, so that combines to 5x, minus 6. Negative 1 times 6 gets me negative 6. In the other cross, 6 times 2x is 12x. 6 times 4 is 24. Since I've got an x squared term, I know I have to factor, which means I've got to get it equal to 0 first. Okay, so when I'm going to move my terms all over to one side, I subtract 12x, so I'm left with negative 7x. Subtract 24, I'm left with negative 30. And I actually factored this one wrong. It should have been x minus 10 and x plus 3. I'll have to change that on my key. Because they had to multiply to get to negative 30. So that means I know the signs have to be different. And add to get to negative 7. Okay? So if this was an x plus 3, you would have gotten an x of 10 and an x of negative 3. Okay. Now for 1 through 4 on this review, I had just given you proportions. I didn't give you any sides or angles or anything like that. Okay. So I could have negative x values. If I look here, now remember this is a negative 3 because I messed up the sign here. If I were to plug in a negative 3, I would have negative 4 for this side length. I don't know about you, but you know, if I were to go into Lowe's and ask for a piece of board that was negative 3 feet long, they would probably look at me a little strange, okay? Because that's not possible. It's not real life, okay? So, in this case, when I go to plug in that negative number, it doesn't work out, so I'm going to exit out. My only one that does work is the 10 here, okay? So remember, this should have been x plus 3 for that factor, so it would have been negative 3 for that x. Remember, that one does not work. Alright, so for 7-4, people always seem to be kind of confused with geometric mean, and it's kind of like riding a bike, okay? It's not too bad once you get in the habit of doing it, okay? So if you think about the normal mean that you've all grown up to love and endure, right? You added two numbers and then divided by 2. It was the average, okay? When you're doing geometric mean, it's a little bit different. Instead of adding the two numbers, you're going to multiply them. And instead of dividing by 2, you're going to take the square root. Okay? So when I look at number 23 here, we're just trying to find the geometric mean. So I've got to multiply 9 and 16, and then I'm taking the square root. So 9 times 16 is 144. Take the square root, it's 12. For 24, again, I got a 5 and a 10. Multiply, I get 50. Take the square root. You've got to break it down. 50 breaks down into 5, 5, and 2. So I've got 2 pairs of 5, or 1 pair of 5, excuse me. So the 5 comes out. The 2 is left inside here. Okay, so square root of 50 is the same thing as 5 root 2. Okay. For 25, 6 times 15 is 90. Take the square root of it. You should break it down into 3, 3, 2, and 5. The 3's paired up, comes out. The 2 and the 5 didn't pair up, so they have to multiply and stay inside. Okay. Now, there's 2 ways that you can find geometric mean. That's the easiest way. You can also set up a proportion where I'm going to kind of show an example here with the y, where instead of multiplying and taking the square root, you have the 2 numbers that are the geometric mean in one cross, and you have the y, or up here I would have had x, in the other cross. Okay. Either way, you're still multiplying 2 numbers, and then since the other cross is y squared, you'd have to take the square root. Okay? So when I look at 26 through 29, yeah, all of these I'm taking the geometric mean. Okay? And there's really only two rules here. Okay? Either the centerpiece is the geometric mean between the two parts that it touches. In this case, it touches 1 and 4. Or, if I don't have the centerpiece, maybe I've got one of these legs, it's not touching both 1 and 4. It's touching 1, and I gotta use another number, so I'm gonna also use the whole thing, which is 5. So when you look at my geometric mean here for x, I've got to find the geometric mean between 1, which it touches, and 5, which is the whole thing. Okay? So I've got 1 times 5 is 5. Take the square root. I can't break that down any. Okay? For z, similar process. Z touches the 4. Doesn't touch any other number, so that means I got to use the whole thing of 5. So 4 times 5 is going to be 20. Got to take the square root of it. Square root of 20 breaks down into 2, 2, and 5. Pair of 2's comes out. 5 stays inside. Okay. Oops. Oh no, my battery's almost dying. Oh, never mind. I got an hour. Hopefully it won't take an hour, right? For y, the y one's a little bit different, because you'll notice the y touches both parts. So that means I'm multiplying the parts, not the whole thing. So you'll notice I'm only multiplying 1 times 4, then taking the square root. Okay. So when I look at 27, if I look at y again, it's touching both parts. It's touching the 3, and then I subtracted 3 from 10 to get 7 for the last part. So y is touching 3 and 7. So that means y is going to be the geometric mean between 3 and 7. So that means I got to multiply 3 and 7 and take the square root. So I've got the square root of 21 here. Could have also set up the proportion. That works. Z is touching the 3. It's also touching this whole side of 10. You notice it has nothing to do with the 7. 7 is way on the other side. Okay? So Z is touching the 3 and the whole thing of 10. So that means Z is the geometric mean between 3 and 10. So that means I've got to multiply 3 and 10 and take the square root. So 3 times 10 is 30. Take the square root of 30. Can't break it down. I got 2, 3, and 5. Nothing pairs up. So I'd have to leave it as square root of 30. For x, you'll notice now it is not touching that piece of 3. It's only touching the 7 and the whole thing of 10. Okay. So now I've got the square root of 7 times 10, which is 70. When I go to break it down, I get 7, 2, and 5. No pairs. So I gotta leave it alone. Okay. To kind of check your work, remember the hypotenuse of these small triangles have to be the biggest numbers. So between 3y and z, I know z has to be the biggest. If I were to take the square root of 30, it's like 5, in between 5 and 6. Okay. Same thing with x here. I know it has to be the biggest between 7, x, and y. Square root of 70 is in between 8 and 9. Okay. So I know it's the biggest. For 28, same process here. Man, it's actually snowing outside. Sorry, I got a little distracted. Who knows, maybe I'll be off tomorrow, right? I doubt it, though. So for 28, again, y is right in the middle. So it's in the middle between 144 and 25. It's touching both pieces. It's the geometric mean between those two. So I've got to multiply 144 and 25, and then take the square root. I'm going to kind of give you a hint here. If it's a bigger number, like 3,600, I'm probably not expecting you to break down a square root like that. Be a whole lot of numbers. Okay. Try it first in your calculator. See if the square root comes out evenly. Okay. In this case, square root of 3,600 is 60. For z, it touches the side of 144. Doesn't touch the side of 25, so instead I've got to use the whole thing of 169. So 144 times 169 is some big number. When I go to take the square root, I get 156. Okay. For x, it's touching the side of 25. Need another number, so I got to use the whole thing of 169. When I go to multiply, I've got 25 times 169 is, I guess, 4,225, which is 65 when I take the square root. Remember, multiply and take the square root. For 29, again, y is in the center, so it's touching both the 5 and the 4. So that means y is the geometric mean between 5 and 4. So that means I've got to multiply 5 and 4 and set it equal, or take the square root of it, excuse me. Okay, so y is going to be the square root of 5 times 4, which is square root of 20. When I break down 20, I get 2, 2, and 5. So the pair of 2's comes out. The 5 is left inside. For the x here, it is touching both the 4 and the whole thing, which is 9. So x is the geometric mean between 4 and 9. So that means I've got to multiply 4 and 9 and then take the square root. So 4 times 9 is 36. When I go to take the square root, it is 6. Z, similar process. It's touching both the 5 and the whole side of 9. Has nothing to do with the 4. So that means z is the geometric mean between 5 and 9. So that means I've got to multiply 5 and 9 and take the square root. When I go to take the square root of 45, I break it down and I have 3, 3, and 5. Pair of 3's comes out. 5 is left inside. Okay. So in the last video, I will have the last page.